The adapter design pattern is used very widely. You already have experience using it, even without knowing that. I will tell you in a few minutes where that was. What does it do? Well, let's look at this situation. Suppose there is a person who understands English. If you speak to that person in English, that person thinks in English. Let's say that person also knows German. So if you speak to him in German or her in German, that person still thinks in English, but understands German. But then let's say the person is supposed to or required to speak to somebody who only knows French, all right? Then this person doesn't understand French, there is a problem. So we have a new requirement that is important to understand. We have a requirement of this person speaking to a French-speaking individual. And we have a problem here. What is the solution? The solution is obvious. We need to get somebody who knows French and can interpret what that French-speaking person is saying. So we get an interpreter or a translator who can translate or interpret the French, perhaps into German. That is fine. So what we can do is, although this individual cannot understand French, the interpreter can translate, or rather interpret, I should say. The interpreter can interpret, or the translate can translate the French into German, and then this person can understand that German and think in English. So the requirement that this French be understood is done in a roundabout way by having an external agent who can do a bulk of the work. So this person does a great deal of the actual work of understanding the material. Okay. So similarly, in software, we think of all the time of creating modules that need some new functionality. So imagine that you're told to create a new program that has some certain functionality, some new functionality. So maybe you are given an interface, a Java interface that says, okay, implement all these methods that satisfy these requirements. All right. You can, one option for you to solve the problem is to start from scratch, write all the code from first principles, and that is probably going to take a lot of time. An alternative would be to use an application programming interface which does a great deal of what you want to achieve, but not quite what you want. Here is where I want to draw your attention to the first programming assignment. You had to create entity lists, a list of entities. One such thing was a building list. A second thing was an employee list. So for that, I think some of you used the linked list class in java.util. So instead of using arrays or a linked list of your own construction, you used a tool or used a class that is already available in Java, like linked list, and instead of adding into an array of your making, whenever you had to add an employee, you would add to a linked list, the java.util.linked list object. So a bulk of your work was actually done by the linked list class. That object that you used is called an adaptee, and you are adapting to the new requirements. So you are an adapter. Your class employee list was an adapter that used the linked list class as an adaptee. The adaptee is what you use to satisfy the new requirement. So in this example, this person who is interpreting or translating is the adaptee, and the whole thing is an adapter. Of course, that analogy only goes so far. So the adapter design pattern uses existing code, but we don't want to use the source code. For example, you did not copy the source code of java.util.linkedList. You use that class, the bytecode that we have in the library. If you use the source code, you'll have to copy all that stuff into our project, and then we probably will need to understand what is going on in the code, which is very difficult. And if there are bugs, we will inherit all those bugs. But of course, that is true with the bytecode too. But if Java comes up with a fix to the bugs, we will not get the benefit of that in future versions. So we don't want to copy the source code. Instead, we want to use the binary version, the executable version, or the bytecode version as far as Java is concerned. We don't need to understand the internals of the code. We just need to know what each method does, nothing more. So viewed in a different way, let us say our interface requires 4 methods to be constructed. So I distinguish between their functionalities by colors. So red means one functionality. This blue means a second functionality. The light green one is a third functionality, and the other green is a fourth functionality. So there are 4 methods that we need to implement. Let's assume that there is a module available. You searched in your libraries, in your packages, and found a module that does exactly the red functionality. But the other functionalities are close, but not quite, right? This blue thing that we have, and another one that does slightly, it's bluish, but a different shade. This is green, a different shade of green. This is also a different shade of green. So these 3 things are close, but not quite what we want. This one is exactly what we need. So this can be used exactly. This method can be used exactly. The other ones have to be modified. So what do we do? For each of the modules that are close, we add some kind of a wrapper. We put some extra code that would adjust its functionality to suit the required functionality. So this dark green, if I may call that, functionality is modified in some way to provide this light green functionality. Similarly here and here. The red functionality, I don't have to touch. That is the principle. So we will see an example in another video.